Hey, what's going on, guys? My name is Davila. Welcome back to Save Our System IT. Today I'll continue the second part for the Busybox series. To understand the blockdev command, first you must know what block devices are. In computing, specifically data transmission and data storage, a block, sometimes called a physical record, is a sequence of bytes and bits, usually containing some whole number of records having a maximum length, a block size. Data thus structured are said to be blocked. The process of putting data into blocks is called blocking, while deblocking is the process of extracting data from blocks. Block data is normally stored in a data buffer and read or written a whole block at a time. Blocking reduces the overhead and speeds up the handling of the data stream. For some devices, such as magnetic tape and CKD disk devices, blocking reduces the amount of external storage required for the data. Blocking is mostly universally employed when storing data to 9-track magnetic tape, to flash memory, and to rotating media such as floppy disks, hard disks, and optical disks. Most file systems are based on a block device, which is a level of abstraction for the hardware responsible for storing and retrieving specified blocks of data. Though the block size in file systems may be a multiple of the physical block size, this leads to space inefficiency due to internal fragmentation, since file lengths are often not integer multiples of block sizes, and thus the last block of a file may remain partially empty. This will create slack space. Some newer file systems such as BTRFS and FreeBSD UFS2 attempt to solve this through techniques called block suballocation and tail merging. Some other file systems such as ZFS support variable block sizes. The utility blockdev allows one to call block devices and modify block sizes from the command line. Bridge control is used to set up, maintain, and inspect the Ethernet bridge configuration in the Linux kernel. An Ethernet bridge is a device commonly used to connect different networks of Ethernets together, so that these Ethernets will appear as one Ethernet to the participants. Each of the Ethernets being connected corresponds to one physical interface in the bridge. These individual Ethernets are bundled into one bigger logical Ethernet. This bigger Ethernet corresponds to the bridge network interface. The command bridge control @bridge name creates a new instance of the Ethernet bridge. The network interface corresponding to the bridge will be called name. The command bridge control delete bridge name deletes the instance name of Ethernet bridge. The network interface corresponding to the bridge must be down before it can be deleted though. The command bridge control shows all current instances of the Ethernet bridge. bunzip2 is the equivalent of bzip2, the -d option, and it decompresses all specified files. Files which are not created by bzip2 will be detected and ignored and a warning issued. bzip2 attempts to guess the file name for the decompressed file from that of the compressed file as follows. Filename.bzip2 becomes filename. Filename.bzip becomes filename. Filename.tbzip2 becomes filename.tar. If the file does not end up in one of the recognized endings, which are bzip2, bzip, tbzip2, tbzip, bzip2 complains that it cannot guess the name of the original file and uses the original name with the .out appended. bunzip2 will correctly decompress a file, which is the concatenation of two or more compressed files. The result is the concatenation of the corresponding uncompressed files. Integrity testing with the -t option of concatenated compressed files is also supported. bzcat or bzip2, the -dc options, decompresses all specified files to the standard output. So basically it's the cat command for a certain type of archive, the type of archive constructed using the bzip tool, to show in the terminal the content of the archived file. bzip2 compresses files using the Burrows-Wheeler block sorting text compression algorithm and Huffman coding. Compression is generally considered better than that achieved by more conventional LZ77, LZ78 based compressors and approaches the performance of the ppm family of statistical compressors. The command line options are deliberately very similar to those of GNU gzip, but they are not identical. bzip2 expects a list of file names to accompany the command line flags. Each file is replaced by a compressed version of itself, with the name original name.bzip2. Each compressed file has the same modification date, permissions, and when possible ownership as the corresponding original, so that these properties can be correctly restored at the compression time. Filename handling is naive in the sense that there is no mechanism for preserving original file names, permissions, ownerships, or dates in file names which lack these concepts or have serious file name length restrictions, such as MS-DOS. bzip2 and bunzip2 will by default not override existing files. If you want this to happen, specify the -f flag. If no file names are specified, bzip2 compresses from standard input to standard output. In this case, bzip2 will decline to write compressed output to a terminal, as this would be entirely incomprehensible and therefore pointless. The calendar utility displays a simple calendar in traditional format, and ncal offers an alternative layout, more options, and the date of Easter. The new format is a little cramped, but it makes a year fit in a 25 by 80 terminal, and if arguments are not specified, the current month is displayed. The cat command concatenates files and prints their contents to standard output, meaning that we will be able to see it in the terminal. When we use cat on a text file, we will not be able to modify the file in any way, but all the text written in that file will be displayed in the terminal. The chgrp command is used to change the group ownership of a certain file or files as a security measure. If you want to give permissions to a command to some group, you can use this command. In case some of you may be wondering, yes, there is a difference between chown and chgroup. First of all, the chown command is used to change ownership as well as the group name associated to a different one, whereas chgrp can change only the group associated to it, to a file. Many people say that regular users are only able to use chgrp to change the group if the user belongs to them, but it's not entirely true. A user can use chown and chgrp irrespective to change the group to one of their groups because chown is located in the /bin folder, so everyone can use it with some limited access. And that's about it for today. Don't forget to like, share and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sosit.co. Again, that's www.sosit.co. Thanks for watching and have a nice day.